to estimate the limit of a function at a given point, looking at a graph, you're literally just going to imagine that you're tracing the graph with your pencil from both sides and imagine what you're getting closer and closer to for the value of your function. So for this first graph, let's find the limit as x approaches -1. So if I'm coming from the left-hand side, I'm getting closer and closer to -1 for my x values, but for the value of my function, I'm getting closer and closer to the value of the function 3. This way, coming from the right-hand side, I'm getting closer and closer to 3. So I'm going to write down and estimate that the limit as x approaches -1 of g of x is equal to 3. Now the actual value of the function, if we look at this, g of x is actually equal to 4, because this is the value of the function. This point right here is open, meaning it's all the points leading up to that, but that point at 3, that point 1 at x equals 1 and y equals 3 doesn't exist. At that point, at x equals 1, the value of the function hops up to 4. So you can see that the value of the limit and the value of the function don't necessarily always have to be the same. The limit is what am I getting closer to? Okay, same thing for the second graph. If I want to find the limit as x approaches 2 of h of x, I'm going to look to see, when I trace it, coming from the left, I'm getting closer and closer and closer to -1. Coming from the right, I'm getting closer and closer and closer to -1. So I'm going to estimate that the limit as x approaches 2 of h of x is -1. Now the value of the function at 2 does not exist. There's a hole there, which means there is no point there at 2, -1. And there is no other value anywhere along x equals 2 for the value of the function. So you can see that the value of the function doesn't have to exist for you to have a limit. Again, for the limit is a constant